Hello, it's Bruce here inside the Safe Living Technologies fully anechoic RF chamber. Right now I'm doing final testing of the RF module for the upcoming Safe and Sound Pro millimeter wave RF meter. And this meter is specified to cover 24 to 40 gigahertz, and it's very sensitive. And what I'm doing here is power linearity testing. So I'm stepping through all the different frequencies in a range from 24 to 40 gigahertz, and I'm stepping through a variety of power levels in 3 dB increments to be sure that the unit is behaving as expected. It's taken a long time to get this far, but very pleased and excited with the results. Now this test, because it's direct signal injection to the RF module, it doesn't need to happen in this anechoic chamber, but because a lot of our test equipment is already in this room, it's just convenient to do that in here. When it comes time for me to do the radiated tests with the antennas, then I will not be in this room for my own safety. I'll be sitting in the control room. So I think I'll be able to get a few shots of that process for you as well. Okay, 24 gigahertz, 575, 25 gigahertz, 634, 26 gigahertz, 570, 27 gigahertz, 623, 39 gigahertz, 515.6, and 40 gigahertz, 398.8. 398.8. Okay, next power level. So these readings that I was taking are levels that are internal to the meter and are not proportional to the displayed reading. Because what's happening next, we've got the RF module here, but in our antenna and feed line design, we compensate for frequency response from the RF module. And so by the time you combine the antenna and this fantastic little RF module, we get a relatively smooth response from 24 to 40 gigahertz. Okay, so now it's time to attach the transmitter antenna. I'm going to double check that the signal generator RF is off, because I do not want to be in front of this antenna when this thing is actually sending out RF. And this is a very accurate lab calibrated antenna that covers the frequency range of 18 to 40 gigahertz, and I'm going to be firing it this way, lengthwise into the chamber. Okay, so what you're seeing now is a view from outside the chamber with the camera zoomed into the here at the test point. So we've got the RF module with our little omnidirectional antenna that we affectionately call Stubby. And the surface that it's resting on is open cell foam, so it's virtually transparent to RF. And you might have noticed in earlier videos, the floor that I'm walking on, even though there's RF anechoic tiles, these cones pointing up, there are special walking platforms that are again open cell foam that can take some weight. And so when I'm in the chamber, essentially I'm not disturbing the anechoic tiles, and also the walking surface again is virtually transparent to RF signals. So what's happening is we've got the antenna, transmitter source antenna, and we're going from 24 gigahertz to 40 gigahertz and firing down here into the chamber at the test point, and we'll just be logging some data. Welcome to the control room. This is the area with the equipment that controls the equipment that is in the anechoic chamber. And that anechoic chamber is in the other room. So in the last year and a half, and especially the last few months, this is where I spend a lot of time. So what's happening is we're setting up, this equipment is telling the, in this case today, the signal generator in the anechoic chamber. I am generating a constant 1,000 microwatts per square meter at the test point, okay, that I showed you in the previous section of the video. So at that test point, at each test frequency, we're maintaining a constant power level of 1,000 microwatts per square meter. And I'm reading again, this is an internal reading to the meter. So, so what we're seeing on the screen is not the final user interface, the display. These are just voltages that we need to know to write the software for the meter. So in this case, I'm right now at 32 gigahertz, and we can see right now we've got yeah, it's looking good. We got the expected reading. There's 661. Okay, I'll log that. And then in this case, I'm going to poke up to 33 gigahertz. And from our calculations, that is the same power level. And yes, as expected, we see a slight drop. Now we're down to 571. I'm not sure if you can see that monitor on the video or not, but anyway, this is how it goes. Like I said, today I'm doing the 1,000 microwatt per square meter tests, but with our horn antenna, I'm testing down into the 1 microwatt per square meter power levels from 24 to 40 gigahertz. Anyway, I hope you enjoyed this video. We're really excited about this new meter that's coming out shortly. Thanks for watching. Bye.